class is we're going to talk about Jefferson's method and Adams' method. So remember that I'm just going to do a quick review of the stuff we talked about at the end of last class. Remember in Hamilton's method, you divided every state's population by the standard divisor and rounded the result down, just chopped off the decimal. Okay, and up until now, everything seems pretty fair, but when we start handing out surplus seats, some states might start to complain, right? Why did they get an extra and I don't? So Jefferson's idea was, let's make it so that there are no extras. We're going to tweak the divisor so that when the quotas are rounded down, there are no surplus seats. So to make this idea work, we need all the quotas to be a little bit bigger, right? All the quotas need to be a little bit bigger so that when we round them down, we don't have too few. So we want all the quotas to be a little bit bigger, which means we need to make the divisor smaller. The number you divide by is smaller, the answer will be bigger. So then we did the example with Parador's Congress, same example we did with Hamilton's method. But instead of a standard quota of 50,000, when we use 50,000, it only adds up to 246. So we said, okay, this is too small, so I'm going to make my divisor smaller. So instead of using the standard divisor of 50,000, we used a modified divisor, a different divisor that's a little bit smaller, 49,500. And when you divide all of your populations by 49,500 and round it down, it adds up to exactly 250. So now I have no surpluses to give out. Though we did have this weird result where state B got 140 seats, and that seems a little weird, a little wonky, because their standard quota was 138.72, which is their exact fair share of seats. And it seems weird that we would give them something other than 138 or 139. So here's the summary of Jefferson's method. You have to find a suitable divisor D. That's step one. And that's the hardest thing. That's the thing I haven't told you how to do yet, right? I just magically made up the number 49,500. Okay, so that's step one. Then, using D as your divisor, you compute each state's modified quota. Then you apportion each state its lower quota, that is round down. Okay. So the hard part of Jefferson's method is step one. And this is a little flow chart that can help you with it. Okay. So use D to find the quotas. So usually you'll start with the standard divisor. Just start with the standard divisor. It might work, right? Round everything down, add them all up and call the sum T. Is T equal to the number of seats in Congress? Yes, then you're done. If not, if it's too small, make D smaller, and if it's too big, make D bigger. So it's just a little, and then start again at the beginning. So the way you find the modified divisor is a guess and check method, right? It's a guess and check method. You just know which direction to go in. You might go too far, and then you have to adjust. Okay. So it's a guess and check method. So it's not, you don't know immediately how to adjust your divisor or how much to adjust it. But you start to get better at making guesses once you've done a few of these problems. And what was I going to say? I can't remember. Oh, and there's more than one divisor that will work. So you're not trying to narrow in on like one specific number. There's a range of divisors that will work. Okay, so it won't take as long to find as you might think. All right, so let's go through how we might have come up with that 49,500, that magic number. Okay, so here I have my populations. This is the same Congress of Parador, and again, we're apportioning 250 congressional seats. So we got the standard divisor was 50,000, right? So I start by getting my standard quotas, just like I would do with Hamilton's method. Divide each population by 50,000 and I get my standard quotas, right? Total's 250. So my next step should be to round everything down because that's what Jefferson's method does, right? Round down or chop off the decimals. So my lower quotas are going to be 32, 138, 3, 41, 13, and 19. Add those all up, and you get 246. Now, 246, is that too big or too small? Too small. So when the total is too small, we need to actually make the divisor smaller, because that will make the total bigger. So I need to make D smaller. So then we just take a guess. We just have to pick something smaller than 50,000. So maybe we go down to 49,000. This is just a guess. The only knowledge I have is that it has to be smaller than 50,000. Okay, so we go down to 49,000, and then let's see what happens. I need to pull up a calculator here. And instead of 50,000, I'm going to divide each population by 49,000 and see what I get. Okay, so 1,646 divided by 49,000, and I get 33.59. So you can see by making that divisor smaller, my quota went from 32.92 to 33.59. Quotas are all going to get a little bigger, and hopefully instead of adding up to 246, it'll add up to 250. All right, so now I have 6,936 divided by 49,000, 141.55. 3.14. $42.67. You might notice I chopped off all the zeros. The answer will come out the same. I just canceled the zeros to save me a little typing time. So like instead of 685,000 divided by 49,000, I can just do 685 divided by 49. Same, and you get the same answer. So 13.98. And then 988 divided by 49, 20.16. All right, so again, adding these up isn't going to give you any meaningful thing, so I just don't fill that one in. Now I'm going to get my modified lower quotas. That is, take your modified quotas, chop off the decimals, round them all down. So we have 33, 141, 3, 42, 13, and 20. And when I add those up, 252, okay. Is that too big or too small? Too big, right? It's too big. So I need to make D bigger, because making the divisor bigger will make the answers a little bit smaller, and then my sum will be a little bit smaller. So 49,000, I knew I had to go down from 50,000. I went to 49,000, but I went too far. Right now I have to make D bigger, but I know that 50,000 was too big, so maybe I'll go somewhere in between, 49,500. So when I use that one, I already know the results because we did it over here, right? I'll just copy those into my new table. All right, good enough. So now you see that we get exactly 250 when you use the 49,500. I'll write them down. This is confusing to look at. So this was 33.25 140.12. Doesn't make sense. And then round them down and I get 33, 143, 42, 13, 19, and that adds up to 250, which means we're done, right? It's perfect. So Jefferson's method is an example of something called a modified divisor method. We just changed the divisor. Two other modified divisor methods were proposed as alternatives to Jefferson's, one by John Quincy Adams and another by Daniel Webster. The only difference between the three is the rule that you use for rounding, right? So in Jefferson's method, we take all the modified quotas and round them down, right? Chop off the decimal. Okay. Our third historical solution, Adams' method, proposed by John Quincy Adams, is almost identical to Jefferson's, except at the part where you round. In Jefferson's, you just chop off the decimals. In Adams, you bump everything up to the upper quota. Okay. So it's almost identically the same. So to find a suitable divisor, we need the quotas to be slightly what? So if you're bumping everything up, when you add them all up, are you going to have too many or too few seats? Too many. You're rounding everything. So when everything's not rounded, if you use the standard divisor with the 50,000, right? If I were to have bumped all these up, so I'd get 33, 139, 4, 42, 14, 20, this would have added up to more than 250. Because with the decimals, it adds up to exactly 250. So if I round everything up, it's going to be too big. All right, so right now, my quotas are too big, right? So I need my quotas to be a little bit smaller. Okay. So to make quotas a little bit smaller, I want to divide by a number that's what, a little bit bigger or a little bit smaller? Bigger. When you divide by a bigger number, the answer comes out smaller. Right? So I need my divisor to be slightly bigger. So it's the same flow chart that you use for Jefferson's method, right? Find the quotas. This time you round up. Find all the upper quotas. Add them up and call the sum T. If T equals the number of seats in Congress, we're done. And if it's too small, make D smaller, and if it's too big, make D bigger. Same flow chart. The only difference is right here in the rounding step, we go up. We bump up to the next number. So for Parador's Congress, here's my populations, my standard quotas, all the same, right? When I add them up, I get exactly 250. And Adams' method says, okay, now bump everything up. Now go up to the next number to get the upper quota. So I have 33, 139, 4, 42, 14, 20. And when they add those up, what do I get? 252, which is too big, right? So how should I adjust my divisor? If my quotas are too big, what should I do with my divisor? Make it bigger. Yep. Because then if you divide by a bigger number, your quotas will all be a little bit smaller. Okay, so I need to make D bigger. Okay, so let's pick a modified quota that's a little bigger than 50,000. What number would you like to try? 55,000? 50,500? Okay, why is that a good guess?
Too much at a time.
Yeah.
A little bit more.
We're not that far off. Yeah, we're only two above what we need to be. And in Jefferson's method, dropping down by 500 worked. So it's a good first guess for Adams to go up by 500. We'll see if it works. So divide each of the populations by 50,500. oops. 50,500. 32.59. 6936. 137.35. 3.05. 41.41. 13.56. 19.56. Okay, so again, adding those up isn't going to give us any kind of meaningful number there. But my next step, because I'm doing Adams method, is to round up, right? Adams always rounds up. So I take all of those numbers, bump them up to the next whole number, and I get 33, 138, 4, 42, 14, 20. And when I add those up, what do I get? 251. They're all the same as the previous, right? This row and this row are all the same except for state B drops down by 139 to 138. So I have 251 instead of 252. Now 251 is still too big, so how do I change the divisor? Bring it up a little bit more, yeah. So I want to make D bigger. So what D do you want to try? 51,000? Okay, let's try it. Take a couple minutes in your groups to do those calculations. So what did you guys find about 51,000? Didn't work. It came out to 249, I think. 248. Okay, it came out to 248. With 51,000. So you had a couple of numbers that come out exact, right? Those numbers should stay the same. They don't require any rounding. Yeah. So it should come out to 248, which is too small, right? So that means you have to make D smaller, right? So 51,000 was too big, but 50,500 was too small. So maybe we should try 50,750. So you can either erase what you had, or you can add some rows on and try 50,750. Then we'll reconvene and see what you guys come up with. All right, let's do 50,750 together. When you divide each population by 50,750, somebody who has them, can you read them off to me? Okay. Yep. Yep. Okay, so adding those up makes no difference. In Adams' method, we're always going to round up. So we're ignoring conventional rounding rules here. With Jefferson's method, you always go down to the number below. And with Adams, we're always going to go up to the number above. Okay, so this is going to be 33, 137, 4, 42, 14, 20. And when you add those up, you get 250. Done. So that is our final apportionment. Anyone see any problems? State B again. This time, last time they got more than they should have. This time they got gypped, right? State B, their standard quota, right, the exact number of seats that they should get in proportion to population is 138.72. it makes intuitive sense that we can't give out a partial seat, so we should either give them 138 or 139. But we've given them 137. So B got gypped. So Jefferson's method gave B an extra, so they came out loving it. But Adams' method gypped them a seat, right? So you can see why the methodology that we use to apportion seats has changed so many times. If this happened to, I don't know, Virginia, they'd be like, no, 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 let's use a method that doesn't do this to us, right? All right, so I'm gonna, yeah, question? Yeah.
These guys, did they actually come up with this stuff, or did it just came after?
No, they actually came up with it, which is what's so amazing, I think, that these were politicians, not mathematicians, you know, but they were thoughtful enough to be able to think about this and come up with good procedures, which you should be able to, because this isn't incredibly difficult math, right? You just have to be thoughtful. All right, so I want you guys to take 20 minutes or so, or however long it takes, to work through this class activity. You're going to practice Hamilton's, Jefferson's, and Adams' methods. You're going to have to create your own table. I didn't give you tables because your homework doesn't give you tables. So I wanted you to practice laying out the table yourself. Yeah. The answers are given at the end, so you can check your work. And then we'll do a little bit of stuff in Excel, and I'll show you how to use that.